the first dog goes to which group, the second dog goes to which group, the third dog goes to. And I end up, you can follow this through, I end up with the dogs randomly assigned to the different food conditions, and I've gathered food data from all these dogs, all randomly assigned to my conditions. And so chances are that among the dogs that ate chunks and lumps, I have some fatter dogs and some skinny dogs, some older dogs and some younger dogs, maybe some bigger breeds or some smaller breeds, because I randomly assigned them. I didn't make any choices. I just said, when you walk in the door, I have no control over that, and now I'm just going to assign you using the block. I'm going to assign you randomly. So this is simple block randomization. Pretty super easy. Everybody okay with how this happened? Okay. Now, it's possible that using this strategy by itself could result in some problems. For example, what if, just by accident, because it could happen randomly, it ends up that the dogs in the chunks and lumps group are pretty consistently a lot bigger than the dogs in the other group. It just happens that way. I mean, it's random, right? It could happen that the bigger dogs all end up in the chunks and lumps group. Well, bigger dogs are more likely to eat more food, and that's going to represent a confound, right? Because now I don't have similarly sized dogs. Now I got bigger dogs eating one kind of food than other kinds of food, and of course they're going to eat more because they're bigger. So I might choose instead to engage in matching. And matching is what I do before I do the random assignment to try and help random assignment work better. Okay, because I'm worried the random assignment isn't distributing individual differences the way I want it to, and it's probably because I don't really have enough dogs. I need more dogs, but I only have so many people who want to bring their dogs in and eat weird food, so I need to use whatever strategy I can to make this work. So I identify an appropriate matching variable, in this case, the size of the dogs. And what I do is I start off, I know all the dogs that are going to come and be in my study, and I get data on all those dogs with regard to my matching variable. And in this case, it's going to be how much do they weigh. And then I'm going to take those dogs, and I'm going to put them in rank order in terms of that variable. So you can see on your handout that what I've done is ordered the dogs by weight. Thor is actually my English bulldog. He's very sweet, big clown. Okay? These are actually all names of bulldogs from Georgia English Bulldog Rescue. I do rescue for them. So these are, I'll say we have all bulldogs, so we're holding breed constant now, but bulldogs vary a lot in their weight. So I take all the dogs, I put them in order, and now I've got group 1. These are the 3 heaviest dogs. Group 2, next 3 heaviest dogs. Group 3, next 3 heaviest dogs. Group 4, next 3, and so forth. Until I get down to the lightest dogs. Always with the heaviest dog at the top of the list and the lightest dog in the group at the bottom of the list. Okay? Now instead I'm going to do random assignment. But I have to do it after I do matching. And here's what's going to happen. Now I'm going to take my blocks, same blocks I used before, and I'm going to apply them to the groups. So now, all right, I've ordered Thor, Toro, and Buddy are the 3 heaviest dogs. Okay. I'm going to use this order. So Thor goes in group A, Toro goes in group B, and Buddy goes in group C. Next group of dogs, group 2. These are the 2nd heaviest group of dogs. I'm going to use a different random order. Now, Orvis is going into group B, Lewis is going into group A, and Champ is going into group C. What's going to happen when I do this is that I will distribute the dogs of different weights evenly. Every single food condition now will have one of the heaviest dogs, one of the next heaviest dogs, one of the next heaviest dogs, one of the next heaviest dogs, and now each of my food groups will be better balanced in terms of dog size, which should reduce the likelihood that that has any negative influence on the outcome of my study. So I've balanced it across conditions by using matching. All right, talk to you next time. Thank you.